Okay, so in this video we're going to start section 8.3. We're multiplying and dividing rational expressions. And then we're going to work with some complex fractions, so we'll do that towards the end. We're going to start with our first, we're going to do two examples. We have our first one here where we have just three different fractions being multiplied together. Real quick, what I'd like to point out is this is the same as 36x times 12x to the 7th times 5 all over 9x squared times 2x times x squared. These are the exact same thing. And these guys, we could look at them as all factors, okay? And so it doesn't matter how I reduce, but I look for common variables and common factors within the numbers that allow me to reduce. And so I could just start quickly by saying, well, I know 36 divided by 9 is 4, and I have one x here and another x here. So notice I canceled these two guys out. Because it is all multiplication, I can just freely cancel out common terms, so it doesn't matter. So I have an x to the 7th here, so if I get rid of an x squared here, it would reduce that to x to the 5th. I have an x squared here, which would reduce this x to 3, and that's just based off of our properties of exponents. I have a 2 in the denominator. Well, I can reduce this 12 to a 6. So notice everything in the denominator is canceled out, and I'm left with just a few pieces. I'm left with a 4. This is a 6x cubed and a 5. So I'm just going to multiply all these guys together. So I have 120 x cubed. And this is just simplifying a rational expression. So we're reducing fractions, and that's all we're doing. Our next example, this is slightly different in the sense that it's not listed as factors. It's listed as separate pieces. And one thing that I want to point out is pluses or minuses marry terms together. Okay? So then that means this x squared is married to the 5x. So I can't break it up unless it's written as a term of multiplication. So in order to do this, I need to factor. That's my first step. So I'm going to go ahead and factor the numerator, and I'm going to get x plus 9, x minus 4. Now, because I have, let me actually factor the denominator first, x plus 4, x minus 4, it's a difference of 2 squares. I'm cruising through some of those basic ideas that we've already discussed in the beginning of the year in first semester. Now I'm looking at this. This is a term multiplied by another term. So if I have common factors, I can go ahead and just cancel those out. It's the same as having, 4x over x. The x's would cancel out because it's all multiplication. So I notice I have an x minus 4 and an x minus 4. Those are the same. They would cancel each other out. And so all I'm left with is x plus 9 divided by x plus 4. And that is my reduced rational expression. These guys right here, this guy right here, and this guy are equal to each other. They're the same thing. And so the idea is what our solution is much easier to work with. So if I had to work with this equation for a very long time, I'd rather deal with the reduced version as opposed to the non-reduced version.